This is the introductory training session for Hyrel 3D software and hardware. So I'm going to do an overview of the Repitrel program and the hardware features on the System 30M. All the positioning features are going to be the same on all of our units. The high resolution engine will have tighter positioning and more accurate repeatability. And bed leveling won't matter on the gantry model, the 16A, because it'll have a different construction. But all the menu options will be the same software drives all of our models. We have a series of buttons across the top that are always available. The left side of the screen is generally for your manual control of the printer and your rendering of your objects. And on the right side, we use this for our positioning, our configuration, and our G-code editing. So across the top, the first button is File. There are a lot of options you've got here. The most important ones for the beginner really is just the exit button. If you get more involved in projects, you can actually save a series of STLs and G-codes and DXF files together as a project, so that you can open up the same environment later or send that to a coworker with similar equipment. And if there's a firmware update, we can use that tool here, but we already have videos on how to do that. The print button starts your job, kill job will stop it. Under the functions, most of these functions that you see here, except for unlock motors, the rest of them are all available on the manual control tab, which is our second tab on the left side. If we want to manually move the bed around, whenever a movement is made, the motors remain locked in place, and you'd have to come here to unlock your motors in order to allow you to push the bed around or the yoke around by hand. The light is for a work light, which underneath the Y arm on the printer, you can turn that on or off. If your emergency stop is out, you can turn that on or off. And you can also use this to test sensors. We can make another video on that, testing the sensors. It's not critical for most people to do. Note that there is no W axis on most models, and there's also no scanner, so just ignore those options. And also be aware that the Z-axis home sensor is not the same as a zero position sensor. So we have 5 home sensors on the Z. You don't really need to worry about those. Under the settings menu, this is where we check, most importantly, to see what version we have. This is Repitrel 2.855, the current production release, although we expect a new one out before the end of the year, 2016. And this update button is not working on this version. Also on this menu, you can go to your printer settings. These will be pre-configured on your device. You can configure them to your preferences. If you make any changes, you want to click Apply and then OK. And this includes the printer shape, which, like I said, will all come pre-configured for you. Also, if you want to reposition your window, this software window takes up the entire screen on the tablet, which ships with every printer, but if you're running it off a separate desktop or laptop computer like I am, you can come to settings and change your border style so you can reposition your window and put it somewhere else or minimize it. However, if you have the border showing like this and you don't have your menu on auto hide, you will not be able to see all of your buttons. So we recommend that when you're actually operating it, you leave it in full border style. Finally, under the help menu, we have some PDFs available. We have tutorials including an overview of this first training session. This PDF will load here in your help window. You can also view it outside the program as a PDF viewer. And this just goes over all the important stuff on the hardware and software and goes into the rest of the first training session where you make sure your bed's level, set your zero position, and load plasticine and make a print. This details how to do the bed leveling with the digital tramming device. We're shipping the analog tramming devices now, but the process is the same. All right. We also have accessory manuals. So if you want to look at the EMO 25 manual, for example, this will show details on what the parts are called, what they do, the theory of operation, some information on the lure tips that you can use with these heads, basic printing tips. There's really no maintenance except it's important to clean your material out at the end of the use. And here's an assembly diagram with our part numbers in case you need to know about that information. That's most of it. You can jump to a team viewer, so if your printer is online and you're not behind some secure restrictive firewall, you can give us your codes and we can jump into team viewer and help you change some settings or do some troubleshooting if you need to. That's most of the stuff on the help menu. This is your clock because we auto hide the menu, so it's nice to see what time it is, and this is an AC or battery life indicator. The alarm button will actually, doesn't do anything right now, but it will let you push Repitrel to the background. So if you have another window open and it gets, maybe it's a confirmation box or something, and you have this guy and it gets hidden behind Repitrel, you can just click on the alarm button to force Repitrel to the background so that you can find those hidden windows. You might not have a keyboard, so Alt-Tab might not be available to you. The reset button will do a soft reset of the motion controller. So if we look at the connectivity to the printer and click the reset button, if there is anything with a communications issue, majority of the time that will clear out those issues. So on the left side, the first tab is 3D view. In here we have a rendering of our build volume and also a limited log of some communications between the printer and the software. So you see we started the program, it automatically connected to the printer, it tells us what firmware is running on the printer, and the buffer's flushed, it connected a couple times, so I did a reset button, and there's no scanner, so just ignore the scanner message. If your mouse is installed, you can left click to change your orientation. You can right click to reposition your model, which I don't have loaded yet, so let me load one. On the right side, I'm going to Project Composer. I'm going to open a GCode file. And I'm going to run this same one that we see in the other videos. And I'm going to also load an STL file. So now left click will reorient the view. A right click and drag, whichever model is highlighted, the right click will reposition that. And if I want to use my scroll wheel, I can zoom in or out, so we can also go to drag just to change my point of view, rotate it around, zoom in, and we can see that. All right, the control tab gives us manual control over the printer. If I load a print head, we'll show that in later videos, where you have control over the flow rate, the prime and unprime settings, or advance and retract, and temperature, fan speed, and a bunch of other controls on here. We see the hotbed is here. We can look through the hotbed. It's currently set to default to 35 degrees, and that's really the only important thing on the hotbed. If I make any changes, I can right click on the flash button, set those new settings up to the printer, and make that a new standard. So if I come back to the main page, I can turn it on or off at 35 degrees. And let me jump over to the right side. If I look at my Comlink tab, if I want to see what I'm sending to the printer, I can click the transmit button. And now if I turn that on, change the temperature, and turn it off, you can see that it sent an M911, which means an emergency command. The next command is going to be at the top of the print buffer and executed immediately. And I set my hotbed to 35 degrees. And when I click the plus arrow, another emergency command set my hotbed to 36 degrees. On tool 91, which is the hotbed, and then finally I turn the hotbed off when I click that button again to turn it off. And clear out this text. I can also home my X and Y. I can go ahead and park, which will bring tool position number 2 to the center of the bed. And if I want to make relative moves, I can go 100 millimeters, 10 millimeters, 1 millimeter. And I can go to a fine move where I can go down, I can make 5 or half a millimeter or 0.05 millimeter or 50 micron adjustments. And you can see what the GCode commands that Repitrel sends to the printer. Each one of these says go to relative distances, do a G0 rapid non-printing move, and on the y-axis a negative 0.05 millimeters, and then go back to absolute coordinates. So that's what all that stuff means. I can also move the bed up or down, but if I move it down 1 millimeter, I can't move it back up 10 because it's going to stop at the logical travel limit. that is set, and we have a whole video on that, but that is set by turning on your Enable Z Calibrate and making an adjustment with this yellow arrow. Anytime I make a yellow arrow adjustment, it allows the bed to move past the old limit if it needs to, and wherever it moves to is set at the new travel limit. The reason we do this, instead of having sensors in there, is because we don't know, since you're manually loading your head, you may have it slightly higher or lower than last time, or you may have a longer nozzle or needle on your print head, or your focal distance for the laser might be different. So depending on the tool that you load and how you have it configured and loaded, you'll have to set your zero position for that tool. If you leave the same tool loaded week after week after week, all you have to do before you power down and exit is send the Z up to the zero position and then turn it off. And when you turn it on, the position that it's finds the bed at when you start up, that's the position that's going to be your Z0 unless you set it differently. Okay, on the Pictures tab, we're going to go over here on the right side and go to the Camera tab. There is a camera built in, and if you connect one after you start the program, you can come here and refresh your camera list. So the tablet actually has a camera built into the front and back. I'm running off my desktop, so you see I have a webcam built into my monitor. I have another webcam that I use for Skype sessions, and then I have the PC camera, which is the one that's built in on the printer. So if I turn that on, we can see that this shoots downward looking at the print bed. So if I put something underneath here on the bed, you can see it with the camera. This is mostly used for configuring the offset between the different tools when you're having multiple heads cooperate on the same print. Other than that, it can be used to remote in and look and see if your print's still going, but it's not ideally positioned because it's a couple of inches behind where tool position number 2 deposits material. But it's there for calibration efforts. So I'm going to turn this off. Also on the camera page here on the right, the camera tab, we see a button for Snap Layer M790. So if we look at our G-code, every time there's a layer change, there's an M790. It executes any new layer actions. And if you have this button checked, then every time there's a new layer, it's going to take an image. It's best done from another camera that you might plug in a USB camera, because like I said, this one's not ideally situated for that, seeing as it's on the yoke and it's in motion during layer changes. But these would all be stored here in a folder named for the G-code, and each image file would be named with a layer number, and you can actually navigate to them if you have them saved here and do a time lapse by playing image after image to watch your build in progress or after the fact. The next tab is the web browser. Because this takes up your entire display on your tablet, you can go and bring up another page if your printer's online. So you might bring up a reference page, or you might pop this up to look at some instructional video or PDF. I'll have a link from the website. The Auxilary Editor tab. This has a slicing log, so if you're slicing an STL into a G-code, this is where that would show up. Also, there's a little buffer here if you want to send some commands to the printer. You can highlight stuff, and I'll subtract that part. You've got an aux editor. I thought this had a send to printer function. I guess it doesn't. Well, I'll just cut that part out. On the aux editor tab, you have a limited slicing log, so your slicing messages, if you're slicing an STL into G-code, would show up here. There's an auxiliary editor, so if you're editing your G-code, you can highlight some of it, copy it, paste it. And then if you're editing your G-code here, you can make sure that the edits you make are the edits you want to make based on your original text over here. There's also a G-code dictionary, which shows our G-codes and our M-codes used on the printer with some sample or explanations here. Some of these are pretty big, so it's easier to read this in some cases if you use a spreadsheet program or a CSV editor and just navigate to the file, which is stored in your repertoire directory. The help menu we went through. The slicer tab, so if you're going and editing your slicer recipes, It'll launch the slicer configuration tool and capture it in this window. And we'll go through a later video and show you what each of these entries is for. There's pretty good tooltips that tell you what each variable does. And you let you select, make any changes you want, save it with a new name, and then select them when you're going to do your slicing. Finally, we have the Programs tab, which is what we call our ecosystems applications. This is a suite of software. It's all publicly available and it's all installed on each printer. Some of them are there just for you to use. Others are there so that Slicer knows where to find the executable and make an external call if it has to add some functionality, for example, converting a step file into an STL or calling up the slicing program, stuff like that. This should all come pre-configured. If you're doing a new install, the wiki's got this location, and you can just apply settings when you have them all pasted in here. That's it for the left side. The right side, the Project Composer is the tab we stay in most. So normally you would bring in an STL file, you'd scale it, position, and rotate it with your offsets, and you'd come to your Slicer tab, you'd pick your recipes, you'd tell it to slice with Slicer, and you wind up with GCode like we have here. GCode, if you have it selected, your GCode shows up over here. Now there's some post-processing you can do right here, so it won't matter with this file, but if I have something for a filament head that's got, sometimes Slicer generates code with really small non-printing moves, so you can come here on your G0, G1 tab, and you can set your limit to 10,000 for upper feed rate. And say you want to change all your printing moves, like right here, all our printing moves except for the very first one are set to 250 millimeters per minute. If I want to set that to 500 millimeters per minute, I can just click that, and now all my print moves are set to 500 millimeters a minute. So this is a way you can take the same G-code and slow it down or speed it up without having to reslice the entire object again. We also have a button called Auto Prep G-code. Like I said, this will go through. It'll parse all of your G-code, and if it finds any really small non-printing moves, and in this case it found 22 of them, it'll just add an E value to those moves so that we don't have to do an extra advance and retract or prime and unprime that often. It just keeps on printing for that really tiny move. That's it for most of the Project Composer. You've got a variety of tabs here that most people never use, and we'll get into these features in a later video. Comlink Tab, I told you how we can show what we're transmitting to the printer. We can also see what we're receiving back from the printer. So every few seconds there'll be a status report from the printer. At this point, since I have no heads loaded, it's only giving me a status from the Hotbed controller, which is tool 91, and it's telling me I'm at 24 degrees. Now if I turn that on, we'll see this number start to creep up, and also over here, that number will start to increase. And we have a temperature plot, and you can use your scroll wheel to affect the scale. So you can see the bed's been at 23, 24 degrees. I recently set it to 35. And I can even enable the duty cycle if I want to see the duty on the Hotbed controller. So now it's running at 80% as the temperature increases. And as the temperature gets close to the set point, you'll see that arc level out and the duty cycle drop. So we're at 31, we're getting closer.
Is this a different problem?
Yeah, it's related, but it's different.
And you see the duty cycle dropping off as the temperature approaches your set point. This data can be saved to a file. You can view the file that you saved before, and it'll track the data from whatever heads you have loaded, and you can tell it which heads you want to show or not show based if they're loaded or not. And now we're reaching our temperature, so the duty's dropping off. Okay, I'm going to turn that off. We don't need to see this stuff right now, so I'm going to clear that text. We're going to move over now to the hardware. I'm going to explain the features of the printer. So this is a System 30M, and this actually isn't even the current configuration because the material spool is different in the new printers. This rod is mounted to this extrusion on the side, and we have a different bracket that holds the feed tubes, the guide tubes. This is where your tablet would be mounted, but I'm running mine off USB cable from a desktop computer, but your tablet would plug in here so that it can communicate and be charged all the time. And all the plastic parts you see on the printer are actually printed on the printer. The same goes for the plastic parts on any of the print heads, because we test each print head and we test each printer, and we do that by printing production parts. This is our bed. We engage the e-stop to unlock the motors. The bed moves in the left and right, and this whole thing moves up and down in the Z, while your print head moves forward and backwards on the yoke and the Y-axis. Each yoke can take up to 4 heads. You can put them where you want. There are USB ports on the top. They're not associated with any particular head. They're just there in case you want to plug in a thumb drive, or you've got maybe the inspector microscope you want to plug up. It takes this communication over USB, or some future item we may add. This is a steel tube, a 2x3 inch tube. It's mounted on a bearing, a 24 millimeter wide bearing. We call this the X arm. It goes up and down in the Z, and this X table or bed, the table goes left and right on another bearing, a 12 millimeter bearing. Attached to this is your aluminum heated build plate. In most situations, this will get up to 80 degrees C. If you enclose this is normally enclosed in acrylic or polycarbonate, and if you have a heater in here, you can get the chamber up to 55 degrees C, and the bed will get up to maybe 85 or 90 degrees C. This is the hotbed controller, so it controls how hot, what temperature it is, how hot you set it to, and manages the power for that. This aluminum plate is supported in the center by a fixed post, and each corner is adjustable and spring-loaded, so that makes it easy to adjust your zero position, make sure the bed's flat, do all that in another video. And we just send a sheet of regular glass that we tape to the bed. We recommend users do the same because it's easy to take it off and clean it if you need to. The extrusion is all our custom design. It's slotted to allow for the panels to slide in and slide out. There's usually a big door here that I have taken off just to make it easier to show people things. There's some additional tool storage on the right. There's some stabilizers in the back to keep the x-axis from moving, or the spine, which we call the z-axis, which holds the x and the y components, to keep it rigid. The spool over here holds your filament. If you're doing filament-based printing, they come through a low-friction guide tube and just seat into the print head. We've got videos on how that works. And there's a top sheet that's normally on most printers. Down here, the emergency stop allows or cuts off all the 12-volt power, so that disables and de-energizes the motors and the heating elements. The power button will bring the printer on and off. The reset button will force a reset of your motion controller. When you do that, you'll also lose whatever zero position you had set, and you'll be reset. The current position will become your zero position. The chamber lights can be turned on or off with this button. We've got an auxiliary button. Some people wire that up to power for their air filter, or I think the heater is too powerful for that, but the air filter sometimes runs off of that. And I can turn the Y-arm light on or off if my e-stop is out with the button on the software. Some people have elected to swap out the white light LEDs with UV LEDs for photo initiation of cross-linking. That's an option that you have. And there's a drawer here for storage, for all the stuff you want to keep in there. And over on the left side, and we'll show you an image of this, we've got a USB connector if you want to drive, or you can drive the printer from a desktop computer. There's your power supply, your power on off switch, and some more USB connectors. Finally, on the yoke, on the spine, we have some additional connectors here. There's a DB9 for old school connectivity. We actually have one user who's using that because they broke their USB connector. There's a USB connector down here where you can run the entire unit from another computer if you have a problem with your interface board. I should pop this up and show you what the guts look like on the inside here. So under this stainless base plate is the inside of the drawer. We've got our power supply, our wiring harness, and I've got a little bit of debris in here. This is our tablet interface board. So the power goes to here. The tablet or the PC you're running with controls through here. And then we have dual USB connections that run up and talk to the spine and also to the yoke. There's some wiring from these buttons to the panel. Nothing overly complex, but it's pretty simple and it does the job. Older models will have, instead of the tablet interface board, will have actual PC motherboard with a SATA drive on it, but we haven't shipped those out in a couple of years. Any other questions? Reach out to us, Hyrel3D at Hyrel3D.com. Find us on the web, Hyrel3D.net and Hyrel3D.com.